Hello, welcome all. Today we are going to learn about SAS. SAS stands for Statistical Analytic System. This course majorly deliver a knowledge about SAS system, SAS programming, automations of SAS, how SAS is going to use in the industry for data preparation, data accessing, data validation, data cleansing, and producing the analytical result for the client. Why SAS is so demanded software in the market? There are various products available in the market for doing all of the jobs. Like for accessing data, we have very powerful tool in the market. For data validation, for data cleaning, data analytics, and presenting high-end graphical user interface reports for the clients. Even though we have a number of softwares in the market, but still SAS is standing on top of all the softwares. What has made SAS so different than the other available software in the market? We're going to view the highlights of the tools which are available and how SAS is different from the current tools which are available in the market. Some of the silent features of the SAS we are going to learn in this course, where SAS can be installed, how SAS can be configured in various operating system, what are the different products which are available in SAS tools which are embedded with the SAS tool, what are the features of the SAS. So in this chapter we are going to learn more about overview of the SAS system, how SAS is designed. Then we're going to learn how to write or how to interpret a SAS program. So basically the tool called as an SAS, which is used for various purpose. So SAS is a company which has built a tool called as an base SAS. SAS has various tools. SAS is having around 200 plus tools available in the market which are going to use for various functionalities. So here we're going to learn how to write a simple basic SAS program in your SAS software. Next, in the third topic we're going to learn the fundamentals of the SAS. What are the silent features of the SAS? Then we're going to learn SAS data libraries. What do you mean by libraries in SAS? How libraries are used to doing all your jobs in SAS. Overview of the SAS system. SAS basically stands for Statistical Analytic System, which is a collection of models that are used to process and analyze the data. The basic concept of SAS is used to access data from various sources. It is used to process the data, where we are going to prepare data as per your analytical requirement. So once your data model is ready, then we are going to use that data for analytical purpose. SAS is very famous for of its analytical capabilities. Many industries use SAS for doing analytical jobs. Major of the companies, around 70% of the companies which use SAS, they use SAS as an analytical tool. Rather than that, SAS can perform a lot of operations. Like if you want to do data entry, if you want to feed directly data into the SAS system, that can be done by writing base SAS program. Whenever you want to retrieve data from different source, so data can be from an RDBMS or it can be from any of the ERP system, then SAS is having capability to connect to those tools which can be pulled into the SAS, and you can perform all the data preparation, all the analytical jobs. SAS is also used for managing data. So many times whenever you want to manage data, when you want to store data, we use powerful database tool as Oracle, SQL, MS SQL Server, My Data, Teradata to store your data. So those tasks can be done in SAS. SAS is not only an analytical tool, but it can do a lot of things. SAS is also used for producing certain reports. Whenever you want to generate beautiful user interface reports, high-end graphical reports, then SAS can be used as an reporting tool. SAS reports can be generated by writing certain amount of base SAS code, that is by using predefined procedures, or it is having certain tools like SAS graphs, which is a tool, SAS GNG, that is Go graphs, and it has a tool called as an data visualization. It has a tool called as an JMP. So all these tools can be used for producing dynamic and beautiful graphs in the SAS. So if you don't have license for certain softwares or certain model like JMP, then you can produce those graphs in base SAS program. Next, statistical and mathematical analysis. Whenever you want to perform any kind of statistical analytics, so statistical can include basic simple doing test of your data like t-test, student test, or chi-square test, to high-end analytics like correlation, regression modeling, ANOVA and COA. So at the time SAS can be used as a analytical tool. So whenever you want to perform certain amount of business planning, or you want to do a forecasting for your existing business, or you want to build a decision support system, then SAS can be used to perform all these jobs. SAS also used for operation research and to manage your projects. Whenever you want to do quality analysis of your data, the data can be from your healthcare domain, or any of the asset domain, or any of the banking domain. So all the standards like quality improvement standards are available in SAS. You can use SAS as a tool for doing data quality. Whenever you want to build any application in SAS, SAS is having capability to develop your own end application. Like we use a tool called as an .NET or Java to build the applications. In the same way, in SAS also we can build the application. So this application can be a standalone application, or it can be a web-based portal. So with the help of base SAS, what we're going to do, so here base SAS is an foundation tool. So foundation in the sense, whenever you want to install any of the SAS product on your machine, so it can be a simple client application or it can be an enterprise application, at that time base SAS will act as an foundation tool. On top of it, you can install any of the SAS product. So in SAS we have 200 plus products which are available in the market. On this base SAS you can install any of the tools whichever you are utilizing for your project. So base SAS will help us to integrate SAS with many of the business solution tools. So when you install a base SAS on your machine, this will help us to connect various tools of the SAS. So those tools are used for your business solutions that can be embedded to perform large scale business function. So whenever you want to build a data warehouse, or you want to build a portal, or you want to build an data mining application, so at the time all this can be installed on your base SAS software. So one of the good point of SAS is that it's very a flexible tool. Flexible in the sense, it can be installed on any of the hardware, it can be installed on any of the operating system. So here for SAS, SAS is not much dependent on the hardware tools, or is not much dependent upon the any of the OS. Simple, just it needs a Java platform to run. If Java is installed on a machine, SAS can perform its task on its own. It is also called as an very integrated software environment. So integrated in the sense, when you install a SAS product, it will ask you what are the relevant tools you want to install. In the sense, if you want to do high-end analytics, if you want to produce certain graphs, or you want to access data from a different source, So all these tasks are designed in the form of a products. So when you install the relevant products at the time, SAS automatically call those software to perform the task. So because of that reason, we call it as an integrated software environment. So which is virtually any setting to access, manipulate, manage, store, analyze and produce certain reports on your data. So here we're going to see some of the salient functionalities of the SAS. So what are the different functions? So as we have seen in the earlier slide, so SAS is used for retrieving and data from a different source, and it's also used for data management whenever you call the data into the SAS. So this is also called as an report writing and graphical tool, which is also used as statistical analysis, for data mining, for business planning, forecasting, decision support, operation research and project management. So whenever you want to perform some quality check QA task, then SAS is also having application to perform the QA analysis. You want to build an application, it can be a standalone or it can be a web application, then that can be done. Also it can be used for building a data warehouse. Some of the features of SAS. SAS is very good in terms of data management. When you're working with a larger client which is having a huge data, for example, if you take a banking domain project, so where you can find hundred thousands of transactions happening every day. So whenever you want to store those daily transactions on your machine and you want to perform analysis from start to end, then it takes a lot of resource. It can be a hardware resource or it can be your software resource, the supporting software. So SAS is very good in terms of handling a huge data. So SAS is also called as a big data software which can be used for to crunch, to slice and perform analysis on your data. So what it can do is that it can process and produce some insight when you have millions of records. If you have thousands of columns on your table, still SAS is capable of handling thousands of columns. One good point about SAS is that it has inbuilt statistical and random number functions. N number of functions are available in SAS. If you want to perform some statistical analysis or mathematical analysis, or you want to do any kind of analysis on a character variable for like the text mining or some analysis on your numeric variable, then SAS can do all the task. It can interact with many of the database which are available in the software. Simple, only a driver should be installed on your machine. If that relevant driver is installed on your machine, SAS can connect to the database and it can pull the data into a SAS machine. It can interact with operating system. SAS can be installed on various operating system. So another good point of SAS is that SAS can deliver an output in the form of an CSV file, PDF file, XML file, or Word document. Or if you have a direct access to a database, directly SAS outputs can be generated on any of the database. SAS can be installed on various platforms. It can be installed on IBM mainframe, Microsoft Windows, Linux, Unix, OpenVM applications. So what are the different products which are available in the SAS? So as I told you, like SAS is having more than 200 products available in the market which are used for various jobs. So here some of the major products are highlighted in the screen. A base SAS, which is a foundation SAS. On top of base SAS, you can install any of the web application. If you want to build a dynamic dashboard, you can install on your machine, on your client machine, on your server machine. So we have a tool called as an SAS Data Integration Studio. So this DIS is used for building of a dynamic data warehouse on your machine. It has an enterprise business intelligence server. So when you are installing a SAS on your machine where hundreds of users are connected, where you are accessing data from various sources and you want to build a central repository, and end users can dynamically pull a data or an information. In such case, SAS has built a very powerful BI server. With the help of this BI server, you can access any kind of application installed on your machine. Application, the SAS applications which are installed on your machines. So enterprise computing, enterprise guide. So enterprise guide is a GUI based programming tool. Enterprise miner, which is used for data mining. So whenever you want to deliver information on your web, so that your end user or client can just log in on your application, and you want to see a dynamic reports, or you want to build or you want to customize the reports on his own way, then it has a very powerful IDP, so that is information delivery portal. Information map studio, which is used to map between the web applications and the client applications, which has SAS also having an OLAP cube viewer. So whenever you have designed an OLAP cubes, so those cubes, if you want to visualize on your web application, so with the help of viewer we can view all the OLAPs cubes which are designed in your SAS. SAS is having access to the PC files like an Excel file or CSV file, text file, which is stored on your machine, or data is stored on your any of the server. Then you can access to the all the PC files. Similarly, SAS has various tools as AF, SCL, assist for calculation. If you want to connect to SAS to different VMs or different application, so all these tools can be used. Like we have tool as ETS, that is econometrics, time series, FPS, GIS, SAS graphs to build beautiful and dynamic graphs. When you want to generate certain insight with the Einstein insight tool, we can generate. Like if you want to do the operation research jobs, then SAS OR is used. For clinical application, we have tool called as PH clinical. To perform the quality analysis, we can use SAS QC, SAS. Similarly, we have various tools which are used for various purpose. So these are most widely used tool for your enterprise applications and also for your standalone applications. So what are the applications of SAS? So these are the applications of the SAS. SAS can be used for business intelligence, for financial management, human resource management, CRM, clinical data, money laundering, text mining, and many more. So which means SAS can be used in various industries. Only SAS need is that it needs only data. If you have data, you can deliver any kind of information to your end users or to your clients. So here we're going to see some of the component of the SAS system. Like whenever you're going to install a SAS tool on any of the machine, so it can be a server, it can be a standalone desktop machine. So what SAS is going to do is that first it install a base SAS as a foundation tool. Then on the top of base SAS, you can install any of the tool. For reporting tool, for data access, you can use a data access. For web application, data management, visualization, analytics, business solutions. So all these tools can be installed on top of your base SAS. So this was just an general information of the SAS tools and some of the silent features of SAS, what SAS can do, and what's the main strength of SAS, why industry is demanding for a SAS software and the SAS application users as an analyst. So here in this slide we're going to see how a data is converted into information. So whenever you work with any of the tool or any of the company. So normally we do all the major four major jobs. As one part will be a data access, second part is a data management, third is analytics, and fourth is your presenting. So whenever you work with any of the uh, analytical application, data analytical projects, so in such case these are the major thing what everyone will do. As a programmer, you do some data preparation, data accessing, data validation, and data cleaning. As an analyst, you can do a lot of analytics, from basic analytics to the high-end analytics. So what this slide is going to tell you is more about than how data is converted to the information. Whenever you want to convert and or you want to create an information, so how data is flows around various sectors. Like first thing is you need to have an access to the data. So access to the data can be accessing a data from an external database or an ERP file, or data can be stored in a text file or CSV file or an Excel file. First you need to pull data into a machine. So here the machine can be a SAS software, or it can be any software. This is a general picture of how data is converted into the information. Second, once you have access to the data, second task what you're going to perform is the data management. So in data management, what exactly you're going to do is that you connect to a database. You will pull only the relevant data to your system. So consider I have thousand millions of records stored on my an external database which has hundreds of columns, but for my analysis I required only fewer records and fewer variable. In such case, you pull only the relevant data which is used for your analysis, or maybe your information is split into a number of table and you need to pull the relevant information all the tables. So in such case what you do is that you perform some merging or you perform some joins operations and you pull the data. So data management is more about your data preparation, where you will find so any loopholes are in the data, or any invalid values has been entered to your table or your cell, and you perform some data cleaning, some data validation. It can include creating of a master data set which has like a concatenating of a table, appearing of a summarizing a data. So all these jobs majorly done by an programmer. So basically programmer will perform a task of accessing, managing, some part of analytics also he does, and presentation. Whereas in data analysis or a data scientist, so what his job is more about finding some insight or some valuable information from the data. So what he does, he performs some basic QA on the data first. Secondly, he do some basic statistical analysis to just see whether he can perform some analytics or not. So next he will do some analytics to generate some information to the client. So once it is done, he has found some information on our data. Next he will do some presentation. So presentations can be in the form of graphs, or it can be in the form of reports, where you can use SAS as a reporting tool, or you can use some other application as a reporting tool. So here SAS has capability to deliver high-end dynamic reports to the clients, so which can be a graph again, various graph, so like a trend line, or you want to see how a population has been distributed, or you want to see the cluster diagram, or you want to see the dendrogram. In such case, SAS has capability to create high-end graphical reports. Whereas many cases when an analysis is done and report is produced, many users will who are comfortable with an Excel tool, so, or any other reporting tools, they will just try to use those tool as a reporting tool, and they do some presentation and will show to the client. But whereas In SAS, we have a capability to build high-end dynamic reports to the clients. Next slide, we're going to see how a data is converted into the information in SAS. So this is one example which demonstrate you how data is converted into the SAS. For example, if you want to pull a data from an Oracle system or from an Excel system or SQL, so all this can be done in your data step or by using some of the global statement. So once you have access to the data, you have done all the data preparation in your data step, you'll use certain procedures to build some high-end graphical reports. That reports can be in the form of a simple list report, or it can be in the form of a line graph or a bar chart. So here we're going to see how a SAS architecture is designed. SAS is also called as an multi-vendor architecture. So why SAS is called as a multi-vendor architecture is because SAS can be installed on various systems. You can install SAS on your PC, normally we call as an simple desktop, or in your workstation, on your servers, or in your mainframe. It just required only the basic access of the software. Rest of the job is done by SAS itself. So here they have highlighted some of the silent features of the SAS when installed on your PC. Like when you install SAS on your PC, so that PC can has any one of these OS. It requires only less hardware resource. It's not much dependent on your hardware. Simple, it has all the basic configuration of the hardwares, and SAS can do its job. So when you install SAS on any of these OS, then SAS is having a capability to interact with the user. So it is called as an GUI based software. When you install SAS on the workstation, so SAS is available for all the OS. It's Windows, Linux, Unix, and Solaris. It also required only few or basic hardware resources. It's GUI based. You can install SAS on one machines and accessible for many users. So workstation will support for SAS BI server tier architecture, where you can store all your metadata. You can store procedures for your OLAP cube data on your workstation. Similarly, SAS can be installed on your workstation, where it can install on all the available OS. You can connect to the SAS from a remote location by RDP. Similarly, it is supported for the SAS BI server architecture, where we can support metadata, store process, workspace, and OLAP server. Next, on your mainframe, so SAS has capability to install on the mainframe, where it is going to support for your BI infrastructure, that is your middle tier, where the architecture for your mainframe is a significant enhanced in a SAS software that enables effective explorations of multi-processing. Because when you have a huge data and you want to perform a lot of huge high-end analytics, then no, if you're installing SAS on your normal PC or a workstation, then it will take a lot of time to execute. But when you install on a mainframe where it has various processor, then SAS has capability to split its jobs for various process, and it just at the end it can integrate all the data into a single data. Here, good point of SAS is highlighted at the bottom. SAS is only dependent 10% of the system hardware. Rest of its 90% of the work is taken care by itself. Next, so SAS is having capability to access a data. SAS having capability to connect to any of the database, like it can connect to DB2, Teradata, Sybase, Microsoft, Oracle, ERP system like SAP, and it can pull data into the SAS machine. So next is here we want to see overview of the SAS windows. What are the different available windows in the SAS and what is the use? Next here we're going to see the various windows which are available in the SAS system. So SAS has a window called as an Explorer. This Explorer window is used to manage all your SAS related files or SAS related object into the SAS GUI. Next, a result window which is used to display the result which you have produced in the output window. Enhance editor, so this editor is used to write your program. Log window, which is used to just track whatever the task you have done in your job. An output window is used to deliver output in the SAS output file. So we'll see all these windows in SAS software, how SAS software will look like, how this Explorer window, result window, or enhance editor window, log window, and output window will look like. So here this is a basic window of the SAS. When you installed a SAS machine and you are working on your base SAS tool, this is how your base SAS software or the home page of the base SAS will look like. So here we call it as an a geo-based tool because we can interact this SAS tool. Like we have any other Windows application which has a file menu where you can open, save as, you can import data, you can export data, and in editor whenever you want to copy, paste, do, undo, you can perform all the jobs. In view, whenever you want to view to the SAS file or SAS editor, a log window or an output window or graphical window, so this view option will help us to either open or to close the available window. So we have one more option in the menu bar called as a tool. So if you want to open to some of the tools like a table editor or graphical editor or report editor, then you can open all this editor by going to the tools options. So what are the code which are written in your editor? Like here for example I've written a certain code. You want to submit the job to the SAS compiler. In such case, what you can do is that you can select the first option called as submit to run the code which is available in the editor, or else here we have a shortcut window, a man who is in a mode of running, we call it as a submit button. Just click on the submit, or there is a shortcut key called as an F3. Either any of this option will produce a same output. So next we have some more option like whenever you want to recall recently submitted code. So at the time you can just recall the last submission. You want to see the last time what code I have submitted. So with the help of this recall option we can perform that job. Or you want to submit only the few selected lines, then you can use this option. It is top line or n numbers lines, or submit which is in your clipboard. Like whenever you copied some code, then you want to submit only that code to the SAS compiler, you can select this option. So when you're connected to the remotely, it's a simple, what you can do is that you can use this option to sign in to your remote application where SAS is installed, then you can submit your job. So similarly we have various options like as in remote submission, then remote get, remote display, and sign off. Next, a very important menu option we have, that is solutions. So what this solution is going to do is that whenever you want to perform some analytics on your data, like and if you want to perform some mining, so we have a tool called as an enterprise miner, and you want to see how to perform a data analysis. So this guided data analysis option will help you to perform some analysis, or you want to do some market research analysis, or you want to do some project management or investment analysis, time series forecasting. So all this solution will help us to perform all the jobs what we have seen in earlier slides. So you want to do some development and programming. With the help of this option you can perform those jobs. You want to build some reports, so if we have some of the predefined tools, normally we call as an reporting tools. So this will help us to produce some dynamic and high-end quality reports in the SAS output window. So these are some accessories, like you want to see the registry editor, or you want to see some or you want to browse some metadata. With the help of this access you can perform. Next is your windows. If you want to see the log window, explorer, or output window, if it is closed, so with the help of this window again you can reopen those windows. Or you want to arrange the windows in some different format, in a cascade format, in title vertically, in title horizontally, then so this will help you to perform those jobs. And lastly we have an help option. So whenever you want to learn SAS by your own, so many time what will happen, like your company requirement or your project requirement can be certain different, like which you know or which you may not know. In such case uh, you should have a capability to learn by your own. In such case this help will help you to learn SAS by your own. If you don't have an access to your internet or no one is there to guide you, simple just you can use this help tool to learn SAS by your own. So I will tell you one shortcut way to learn SAS. How simple. Whenever you want to see what's the meaning of that keyword, so here a keyword called as libname, it is already written. If you're a new user, you don't know what is the use of this libname keyword in SAS. Simple, place your cursor on that keyword, then press F1. So it will open an help file which will give a lot of information on the libname keyword. So here it will show you what are the relevant topic which has found in this topic. Just we have to see the what exactly we are trying to see. Just we want to learn a statement called as a libname. Just select that option and click on the display. It will tell you what's the use of a libname statement, what are the different options which are available, what is the general syntax, what different argument you can pass, and at the end it will tell you some example how to use this libname in different case. Okay, so similarly you can get information about all the functions or all the keywords in the SAS. Next here we have certain windows, like we have here a result window, an explorer window, output window, log window, and a editor window. First we'll see these three important windows, that is output, log, and an editor. So here editor is used to write all your base SAS code and to perform your jobs. Any kind of base SAS code you want to write in SAS software, so always that is written in your editor window. So it's very similar to other tool, like other tool which you're going to use like C, C++, Java, or .NET. So there also you will find an editor where you write all your code. Simple, just write your code and submit the code to the SAS compiler. When you want to submit this code to the SAS compiler, simple click on this icon, a submit icon, or press F3 button. So let us just try this example. I'll explain you what this statement means. Simple, just will see. So I submitted this code. You can see in my log it was empty. Now you can see it has some information in the log window. So what is going to tell you what are the code which are going to submit to the compiler. It will display that code in the log file, and with respect to that code what exactly SAS has performed the operation. So it will tell you it has created a library called as an imot, which has used an engine called as an v9, which is at a location, it is d imot project. So basically a log file is used to keep information of all the tasks which are going to do in base SAS. Next, an output window. For example, here I have written some code to display some information in the output window, like I want to print a data which is present in library called as an imot, and the table name is employees, and I want to display only the 10 observations, first 10 observation, and I want to display only a few variables where first name, last name, and I want to display only the employee ID. So before submitting this job, just I want to confirm the table name. Yeah, we have a table name employees. Just will submit this job. Yeah, here you can see in the output window we have some information in the output file. So similarly, any information from a table you want to display into the output, so at the time by using certain procedures you can display that information in the output window. So basically this output window is used to display the output to the external files. So here SAS output window is an internal file. Similarly, you can deliver output to the external file as well. Next, you can view the results in an HTML file as well. So default, this is my output window is my default window, whereas if you want to see in an HTML file, so then you can produce an HTML output where you can add your own title, your own footnotes, and you can do a lot of enhancement in the output window. Next, here we have some explorer window. So this explorer window is to explore libraries. Libraries are your SAS library. Some of the files which are stored in your hard drives are to your computer. In libraries, you can see what are different libraries are available, and within the libraries any dataset name or any object which is or any catalog which was created earlier, then you can access all the information in the library window through your explorer. Next is your results. So any results which is going to generate, so all the results in history are stored in your result file. We have seen some of the important editors in SAS. So with the help of these editors, these windows, you can explore the things which you are normally doing in your programming language. Coming to next slide. This is a home page of SAS environment. Already we have seen the screen which will tell you what are the different editors available in the SAS. Basically, these editors are used for writing of your code, to analyze anything wrong has happened to our code, and to see the output which has been generated by certain procedures. And also here we have two important explorers, that is a result tab and an explorer window. So this is how your base SAS will look like when you open a base SAS on your any of the machines installed. Again in detail, so this is we call it as an explorer window, which will help us to explore all the files of the SAS dataset which are present in your system. This is the output screen which will tell you whatever the output you have generated by using some procedures. A log file will tell you any error or any kind of program warnings generated during your executions. All the informations are displayed to the log file. Basically, log file is used to track to your code what has happened in your previous code which you have compiled and submitted for the compiler. So here in SAS we have a flexibility where you can write your code in two different editor. One we call it as an enhance editor, and another is a program editor. So here we are going to see the difference between a program editor and the enhance editor, when we are going to use a program editor and when we are going to use an enhance editor. So some points of the editors are highlighted whenever you are trying to use an enhance editor. So these are the available features of the enhance editor. Similarly, when you want to use a program editor, so these are the features of the program editor. So let us discuss one by one why to use an editor over a program editor, or when to use a program editor instead of an enhance editor. So when you are trying to use an enhance editor on your Windows machine, so it provides a lot of flexibility. First thing is that enhance editor is available for your Windows operating system. When you install SAS on your Windows, in such case this editor is available to write your SAS code, whereas this enhance editor is not at all available for any of the SAS software installed on other operating system. Second point, it's the default editor for Windows operating system. When you open your SAS session, so you can see the enhance editor which is opened defaultly in your SAS home window. This editor helps us to open multiple instances. So what it means is that whenever you want to open 2 or 3 programs simultaneously, or you want to open a new editor, in such case this editor helps us to open more than one editor in your SAS. So normally this we call as an instance, which is helpful to open more than one instant. One good point about this editor is that code does not disappear when you submit the code to the compiler, whereas in program editor when you submit the code to the compiler, this code is going to be disappear. Last point is it incorporates color coding as you type. What it means is that here we'll see how these points will explain you about the enhance editor. Here the window which I opened, this is my enhance editor. Or you want to open this enhance editor, just simple you can go to file, you can click on the new program. Defaultly the enhance editor will be open, or else you can go to an option called as an view. You can click on enhance editor. If you want to write all your SAS code and you want to perform your job, then this is a simple way to open your enhance editor. Or if you want to open a program editor, just click on the program editor. Just go to the view menu, click on the program editor. So let us see, we'll just try to write certain codes in both the editor. One is in the program editor and one is the enhance editor, and how it's going to make difference when you write the code. So first is I can open multiple instances of the enhance editor. Just simple, this is a one enhance editor, this is the second enhance editor, this is the third, fourth, fifth, sixth, seventh. You can open n number of enhance editor. Whereas if you want to open more than one program editor, SAS will not support. Here I have some code which is written here. And now I'm trying to reopen one more program editor. Let us see whether this is possible in SAS or not. Just I'm pressing here Control N, so it will ask for whether you want to change, you want to save the previous editor. In this case, if I choose yes, this copy will be saved on your hard disk. If I choose no, all the code which are written will be erased and a fresh program editor is available for you, which means you can open only one program editor, whereas in enhance editor you can open more than one. Next, so for example here I'm writing certain statement. consider I'm writing as an proc print data equal to. So here you can see, like when I type data and if I press a space or an equal to, depending upon the procedure which I'm calling here, automatically color changing will happen. If it's a keyword, again it is change the color into a blue. It's a procedure or a predefined keyword, then the color will be changed into dark blue. Next, if I try same thing on my program editor, like I'm typing it as a proc print data equal to, you can see here when I typed proc print data equal to, here no color changing has happened. So this will happen only when I press an enter key. So now the color changing has happened. So this is again a basic difference between your enhance editor and the program editor. Next, in SAS we have a tool called as an enterprise guide. So here we are going to see what's the use of an enterprise guide, when to use an enterprise guide, and what's the basic difference between an enterprise guide and enterprise guide is an GUI based tool where you can perform all the tasks what you can do in your base SAS. So here we're going to see how what are the major features of the enterprise guide and how enterprise guide can be used to perform your task what you can do in your base SAS, and what are the key advantage of using your SAS enterprise guide. So this is one screenshot of the EG software, where it will provide you the feature of exploring all the data set which you are using for your analysis, where you can build your own process, your own project, where you can connect to the server which are available to the OLAP server, where you can display all the results in the result tab. You can view the log, you can view the code, you can view open the table. So this is more about an tool based software, like the task what you're going to do in your base SAS, all those can be done, but here they have made it more user friendly, where it's a GUI based software. So here, instead of writing a code, for example in the earlier SAS we have seen, I have written a code where it will tell you, like I want to print a data. We have used a procedure called then proc print data equal to a table name, and we have used a run statement. Similarly, instead of writing those code, you can use the available palettes to perform the task. So here they are using a one palette called as an summarizing your data, where they are using some statistics like mean, median, mode, and those information they are again displaying in the form of a graph. Here they are using a bar graph. So this can be done without writing a code. So behind it, whenever you use any of these available palettes, behind it it's going to generate a SAS code. If you are going to merge your data or appending your data, building a graph, generating an output, when you submit the code, when you submit this process to the SAS compiler, what is going to do is that it generates a code. So this is how you can build your own project. So for example, what they're trying to do is that first they have created a format. They're applying a format on a dataset called as an orders underscore orient underscore product, where they are again creating an output frequency. So here they're generating output in various format, in RTF file, in a SAS output, and again they are creating a list report here by country wise, a pie chart, again all they are combining all the output to an last final report. So here you can build a process over here. Whenever you want to do any change, just directly go to that point and you can do edit or modify your process. So whenever you want to build a SAS enterprise guide, how you are going to do? Simple, just open a new project, add the data whichever required for your project, run the task, whatever the task you want to do, just add the task to the data and run the code, then customize your results, automate the process. So this is how it generates an SQL code when you use any of the process. Yeah, there defaultly it's create an code in the SAS editor. So here this EG can be installed on your a single machine, or it can be used on the server. So when you install the EG on the server, what is the advantage of that is that any number of user can be connected to one server, or one user can be connected to the multiple server. Or when you use on a local machine, just you can access via various server. Or what it can do is that if your data is residing on XYZ server, if you want to pull the data into your local machine, so this is also helpful to pass the data from server to your local machine. So here in base SAS, normally what we are going to learn, so this slide will tell you an overview picture of the SAS, what you're going to learn. So in base SAS, you'll be learning more about the data step, what is going to do, what is the use of a data step, what are the different procedures are available in SAS and widely used procedures, how to write a macro program, what are the facility of the SAS macros, whenever you want to debug your code, how to debug your SAS code, and output delivery system, what's the use of a output delivery system, when to use the output delivery system. So SAS windowing environment, so what do you mean by SAS windowing environment, where it tells you more about how to interact with the SAS software, how to write a code in your data step, what are the statement can be used in your data step, what are the different procedures are available, what are the different statement can be written for the procedures, and when to use the procedures. So next, coming to the some of the basic concept of your SAS program are the component of your SAS language. What exactly SAS language consists of? Till now, whatever we are seeing, it's just an overview of the base SAS software. Here we are going to see what are the key components of your SAS program, what exactly it contains, and how to understand those. So here a table is displayed at the bottom. Here it tells you what exactly information it has stored. Whenever you see any table in your Excel spreadsheet or any of the data storage tool or even RDMS database, it consists of a variable and an observation, normally called as in rows and a column. Same thing, whenever you open your SAS table, it contains two information. First is a descriptive information and a data values. So data value contains your observations and it contains your variable. Descriptive information or a descriptor information is just a general information which provides about your table. So general information in the sense where your table is created, when it is created, when it was modified, how many observations are there, how many variables are there, what's the data type, what's its length, what is the format, what's the in format, any sorting, any indexing, or any rows has been deleted, on which operating system the dataset was created. So those information can be generated with the help of some procedures, and those we call as an descriptive information, whereas data values is your actual data values which is stored in your table. It contains observations and variables. Variables are your columns, observations are your rows. Next, SAS language element, we are going to learn two important steps. One is a data step or a proc step. Any code you write in SAS, except the global statement, there are few global statements which can be written outside the data step or the proc step. So any statement you write in SAS, normally we write in a data step or a proc step. So here we're going to study what's the use of a data step, when to use, what's the use of a proc step, and when to use. Whenever you want to read a data from an external file, it can be a CSV file, text file, a RDBMS file, then that can be done with the help of a data step. Or when you want to write data to an external files, so that can be done with the help of a data step, or sometime that can be done by using some procedures. We'll see at what time a procedure can be used to read an external file or to write to an external file. So this is used to create a SAS dataset and SAS view. So this data step is used to read SAS dataset or SAS views. Similarly, in a proc step, where we normally use a proc step to produce certain output. So that output can be in the form of an graph, report, table, chart, or a plot. Many times this procedure can be used for summarizing or sorting or importing of some of the raw files. Next, different types to run your SAS session. So whenever you have installed SAS on your machine, so there are different ways are there, like you can run your code in a windowing environment. What are the base SAS tool you have seen? That is your windowing environment. Interactive line mode, the enterprise guide software is normally called as an interactive software. Non-interactive is that normally this is done on your Linux operating system, so or on your mainframe. Batch mode is more about submitting your SAS code in a batch file to your server. Here just they are explaining about the interactive mode and the non-interactive mode. So what do you mean, and when to use the interactive mode and when to use the non-interactive mode in SAS. Next, so whatever we have seen till now is just introduction to the SAS system. Now we are going to see about the SAS programs. So in SAS program we are going to see what are the basic concept of the SAS programming. As a program definition is defined as it's a machine language code which we submit to perform certain task. In the same way, when you write any program in SAS, what we do normally, it's a sequence of steps that we submit for the compiler for the execution purpose. If there are no errors in your code, then SAS will execute that code. So the SAS program majorly contains of two parts. One is a data step, as we have seen earlier, and a proc step. So whenever you want to import any data into SAS, that is done with the help of a data step, or whenever you want to import data from a SAS table which is already present, so that is done with the help of a data step. And we create in data step, we create a SAS data set, and we use some procedures to produce or to generate some reports. Same thing they are explaining here. A data step is typically used to create and update SAS data set, whereas proc step is used to sort, manage, generate reports, and produce some graph and perform some analysis on your table. Here is one example of SAS program. SAS is a sequential programming language like C, C++, or Java. So these tools are also a sequential programming language which executes from left to right and from top to bottom. The same way, any code you submit in SAS, these codes are executed in sequential manner. So here's one example. In this example, what we are trying to do is that we are trying to import a CSV file which is present on your hard drive, and we are trying to create a SAS dataset. In upcoming chapters, we will be seeing in details what are these keywords like in file, in format, input, run, proc print, var, run. So what's the use of all these keywords? When to use these keywords? For time being, just we'll assume like this code is a simple code to import a data from a CSV file. Like already a path for the CSV is specified in the in file statement. By adding some options, we can read this CSV file data into a SAS data set, and we can create a SAS data set. Similarly, here we have a few more example. Like if you want to feed data directly into a SAS system, in such case this can be done by using a keyword called as data lines. With the help of data lines, directly we can feed data into the SAS and we can create a SAS data set. So during that phase, like the values may be separated by comma. In such case, how to read a value is specified by a comma. So we can add some option called as a delimiter, and we can specify what's the delimiter to read this data. So we'll see in detail about all the code. Just it's just a highlight of how SAS program will look like. One more, like there are sequence of statements are available in your SAS program. Any code you write within your data step or a proc step, what it contains some statements. So here we're going to see how to understand when the statement has begun and when the statement has been ended. Two important things always you have to keep in mind to see how many statements are there, or where the beginning of statement is there and where the statement is getting ended. By using two simple concept, that is one is your keywords and another one is your semicolons. Whenever you see any statement is starting with a keyword or it is ending with a semicolon, normally we count it as an one statement, or some case it's a both. Even a statement can start with a keyword and end with a semicolon, we call it as an one statement. Or there are chances like where it may not start with a keyword but it will end with a semicolon. In such case we also call it as a statement. So in our case here, this is a one statement. It's always a good habit to count number of semicolons. It's a second statement, this is a third statement, this is a fourth, fifth, sixth and seventh. Total I have 7 statement, but 4 are in my data step, so this is my data step, and 3 are in my proc step, so this is my proc step. So whenever you write a SAS program, there are some syntax rules are there always you need to follow, but in some cases this rules is directly ignored by the SAS, but it's always a good habit to follow the rules. For example, what the first rule says is that code can begin in any column and can span several lines. So if you take this second statement, like there is a in file, here you can see the first few lines are blank, nothing is written, but it is spanning up to many lines, many columns, and it is ending at certain column number. So this can be done in SAS. There is no restriction like it should start with the first column and should end within certain XYZ column. There is no restriction. It can start at any column, it can end at any column number. The important thing is that always all the statements should end with a semicolon. If you are not ending with a semicolon, then SAS will think there are few more options are available for this statement. Another good feature of SAS is that any keyword you are trying to use or any name you are just trying to write, so at the time SAS will not act as a case sensitive. It's not a case sensitive software. You can write in uppercase, lowercase or a mixed case. It's up to you, whichever you feel comfort. You can use your own style to write your code. Fourth point, SAS format are free format. In the sense, you can see here the code which is written, which is not in a proper order. So here this is actually my one statement. There's a proc print data equal to ima.employees. This is my one statement. Here I can split this statement to many lines, like it's a one line, it's a two line. Here I can write in multiple lines. So this is accepted by the SAS compiler. Only thing it will take care is that it should have a semicolon, or it should begin with a keyword. If I'm not going to write a semicolon, then it will consider this run is an option for the proc print statement. But in fact we don't have this option for proc print. Or you can write multiple statement in a single line. This is also accepted by the SAS compiler. Here the three statement are the libname is the one statement, proc print is the second statement, and run is my third statement. So when you submit this code to the compiler, it will execute perfectly without any errors or warning. Next, so you can add more than one blank space or to separate the word, so that is no issues. It can begin and end in any column, there is also no issues. A single statement can span multiple lines, as we have seen. Several statement can be written on the same line. So here you can see an example for more than one blank space. Here I have multiple blank space, here I have multiple blank space. There is no issues. You can write the code in your own way. It's always a good habit to write in a systematic order. There should not be multiple blank space. Always in one line only one statement should be there, and one statement should not span more than one lines. Next, so here we have an option called as an comments. Whenever if you were not interested to execute certain statement of a data step or a proc step, or you want to inform what the data step or proc step is doing, like those are the new programmers, they sometimes may not understand what you're trying to write, but if you display the code in a layman terms, then the user can easily understand what exactly you're trying to do with the help of those proc step or a data step. Here I've written a statement for below data step, what's trying to do. Similarly, a statement is displayed here for proc print, but these are not executed by the compilers. It's only to understand by the end users. There are two ways are there for commenting of a code in your SAS. One is start with /* and end with star and a slash, or star end with a semicolon. So here we're going to see when to use these techniques. Like here I have three statement. If I'm not interested to execute the second statement, just I want to comment it, I can do with the help of a star and a semicolon. So when I use a star and a semicolon, it's going to comment for only one line. If you want to perform one line commenting, then you can use this option, or if you want to comment more than one line, then you can use this option, that is /* your code, then /*. So for this we also have a shortcut key, like you can use Control Shift and a question mark to comment or to uncomment. Next, so very important, the how to write your SAS program without any error, how to avoid the syntax error. So these are the four important points where you can avoid your code from syntax error. First one is there should not be misspelled keyword. What are keywords you're trying to use? It should not be misspelled. If it's going to misspell, sometimes SAS will identify by its own, or it will throw an error message. Unmatched quotation marks, in the sense whenever you have a starting quotation mark, always it should end within the same line, or it can be ended in the next line, but you have to make sure when you start with a quotation mark, as it can be a single or it can be a double, it should end in the appropriate place. For missing semicolons, then SAS will throw an error message. Try to avoid this syntax rule. Next is invalid options. There are few options which can be used for particular statement. If you are trying to use those options for other statement, then SAS will throw an error message. Maybe SAS compiler will not understand why you are trying to use that option for other statement. The definition of those options are different for a particular statement. Next, SAS data sets. So what's the use of a SAS data sets? SAS dataset contains two parts. One is your descriptive portion and the data portion. Whenever you want to see the descriptive portions of SAS dataset, so that can be done by using a procedure called as proc contains. And if you want to see the data portion, like if you want to see the actual values which are present in your table, so that can be done by using a proc print statement. So let us see what's the use of a proc print, how it works, and what's the use of a proc print and how it is going to work. First we'll see about the proc print procedure. Here I'm using an option as an OBS because I want to display only the first 10 observations. If you don't use this OBS option, then it will display all the variables and all the observations which are present in your SAS data set. Okay, let us submit this code. If you want to submit this code, simple just press F3 or use a submit option. So here it is trying to display the available observations in the output window. So it has 9 observations, so it is displaying all the 9 observations to the output window. So what it's going to do is that it will just display the data which is present. So all the columns which are present in the tables, and it will display the 10 observation to the output window. Next, let us use a proc contains, and we'll see what information you're going to view when I use a proc contains code. Here you can see I can't use this option. This OBS option is valid for only proc print. Submit the code to the compiler and see what information it has generated in the output window. As we have seen, the content procedure is used to view the general information of your table. The general information are like what's your dataset name. Like my dataset name is employees, which is present in my library called as an IMOT. What's the member type? Here member type is my data, or sometimes it can be a view. On which engine you have executed the code. When it was created on January 31st 2014. When it was modified on XYZ time. How many observations are there? How many variables are present in my employees dataset? What's the maximum length for the observations in my employees dataset? So maximum length is like it will just count the number of words which are present in my employees dataset. If any observations are deleted, it will give an example information of how many observations were deleted, any compress, any sorting has done, on which operating system it was executed. And also it will tell you, so this is most about an host dependent or the OS dependent. It will tell you about what's the page size, what's the default length, how many observation per place can be displayed, where this dataset is present, what's the location with the extension, on which operating system it was executed. So here it will also display about the variables, its data type. Type is nothing but your data type. What's the length, what's the format, and what's the in format. So all the available 18 observation information is also displayed in my output window. So all this information can be generated by using a proc contains procedures. When I use a proc print, it just prints the actual data in my output window. So here, if I don't use any options in my proc print, it displays all the variables and observations. If I use an obs option, it displays only the top 10 observations. And if I use a statement called as in var, so var is nothing but the variable, which variable you want to display. For example, I want to display the first name, last name in my output window. Just add that var statement, submit the code to the compiler. You can see in my output window I have only two observations, the first name and the last name. So again, we are going to see in detail like what are the other statement can be used in proc prints or any other procedures, and during what scenario you have to use the statements. This is just a demo to display you how this proc print and how the proc contents will work in SAS. Next is fundamentals of SAS. So whatever we have seen till now is just a basic of the SAS system and the basic of the SAS program. Next, we're going to study about the fundamentals of the SAS. So in this topic, we'll be learning about how to declare a variable in SAS, how to declare a name of a table or a dataset name in SAS. So what are the important point you need to keep in mind while assigning a variable name or a table name in SAS? Like if you have worked with any of the database, the database has certain rules for declaring of the variable. Like the variable name can be up to some characters long, or it can store up to few characters in its variable. In the same way, SAS also has its own standard for creating variable and assigning length for the variable. So here we're going to discuss about the rules for creating the variables, rules for creating the dataset in the SAS system, and also we're going to learn here what are the different type of data types are available in SAS. Like those who work with the other database or any other software, you can find there are various data type has been defined like numeric, character, string, boolean, int, integer, float. So in SAS it's a good thing, like in SAS we have only two kind of variables. So here we're going to see how SAS is going to store its value in these two variables and when to use what kind of variables. And also we're going to see the how SAS is going to store its table, whether it's going to store a table in its SAS memory or into the physical files. If it's going to store in the SAS memory, so where it is going to store. So whenever you want to refer to that data set, how that reference can be made by using some SAS code or by submitting some command to the SAS compiler. So first we'll start with understanding of the fundamentals of the SAS. So in this topic we're going to learn how to define a SAS name. A SAS name can be a variable name, it can be a dataset name, it can be any format or in format which are going to assign for a variable or which are going to create which is not defined in the SAS, or any procedure which are trying to create any options, arrays, labels which are going to assign for the variables, a macro definition or a macro variable, the catalogs, the library reference or the file reference, or any component objects. So we'll see in details what is the definitions a SAS can take when you define a name like a variable or a dataset. So here some of the rules are listed here when you try to define a variable or a dataset name. So first rule, what it say? So any dataset name you are trying to create or any variable which are trying to create in SAS should not exceed more than 32 characters in its length. So within these 32 characters, always first letter of a variable or a dataset should start with an underscore or an English letter from A to Z, followed by characters that can be a letter, it can be a number or an underscore, but no special symbols are accepted by the SAS compiler. Only underscore use is used for assigning a variable name or a dataset name. So when you specify a variable name, it should not contain blank space within the variable name. For example, if you try to assign a variable name as first name, so first name are two different words. So here there should not be a blank space. It can be concatenated by using underscore or just writing both the variables continuously without using a blank space. The variable name can contain any special characters other than underscore. So if you're trying to declare a variable, it can have only underscore. Without or rather than underscore, no other special symbols are accepted by the SAS compiler. So when you define a variable name or a dataset name, it can be mixed case, in the sense one letter can be in uppercase, other can be in lowercase, or all can be in uppercase, or all can be in lowercase. So here it is not a case sensitive. So one example is defined here, like you can declare a variable name or dataset name as CAT, all in small case, CAT, C in capital, or CAT, all are in capitals. So one important point you have to remember that there are few automatic variables which has SAS defined a meaning for those automatic variables. So you cannot use those automatic variable as your own variable name. It can be used as a reference to create a variable where you can store the values of this automatic variable into your SAS dataset, but you cannot override this variable name. So those variable names are as follows: underscore n underscore underscore l underscore underscore numeric underscore character underscore and underscore all underscore. So this cannot be used as your variable name, but these can be used as a reference to assign these values into your SAS dataset. So one important point you have to keep in mind whenever you're trying to use a variable name or a dataset name, so you can write in uppercase, lowercase, or it can be in mixed case, because these are not case sensitive. Next, so the variable name or a dataset name or a library name, array name, what you're going to declare or you're going to use in SAS has certain limit for its size. So when you try to create an array in your SAS, the array name cannot exceed more than 32 characters. Any coroutines you make, it cannot exceed more than 16 characters. Any catalog, any SAS statement, SAS variables, its labels, or the windows in SAS cannot exceed more than 32 characters long. Any libname definition or any file name reference you are going to provide, it will not exceed more than 38 characters. Next, any format for numeric variable or any format for character variable is going to assign will not exceed more than 32 characters. The functions what you're going to create in SAS cannot exceed more than 16. Similarly, like the generation dataset, the informats for characters or informat for the numeric, or the library name, macro variable, macro windows, macros, any SAS dataset, view, catalog, or index cannot exceed more than 32 characters. So this is the maximum length what you can assign for these language elements. It can be less than the maximum length or equal to maximum length, or but it cannot be more than the maximum length for this language element. So here we have a one quiz. So what are the things we have discussed till now? So the rules for creating a variable, the rules for creating a data set, and the maximum length for all the SAS language element. With respect to that, which of these options are correct? For example, if I want to create a SAS data set or a SAS variable, among these which are the valid name I can pass to the SAS compiler. Among 7, just need to identify which are the correct. For second question, they want to create a data set and they want to classify which is a valid SAS dataset name and which is an invalid SAS dataset name. So here 4 is not going to be valid because we are using an hyphen which is not accepted by the SAS compiler, and 6th we are starting with a number, so number are not accepted in the beginning, only underscore or any alphabet is accepted. Similarly, when we try to create a data set, no hyphen symbols are allowed within the variable name you are going to define or the dataset name which you are going to define. Always it should have an underscore. Next, very important, when you want to store some values in some of the columns in SAS. In SAS, those columns can be in the form of a character variable or it can be in the form of a numeric variable, which means SAS has only two kind of data set, a numeric or a character. In SAS we don't have any other data types, only two, a number or a character, which is very good. Just you have to understand how to utilize this variable and in when to utilize these variables. So here what we're going to study is that what is the maximum length or what is the minimum length of a character variable, what's the default length of a character variable, and how many bytes is going to occupy. Similarly for numeric variable, and what kind of value are stored in numeric variable. So let us see first the character variable. In character variable I can store any value, any alphabets, any special symbols, any integer into the character variable. So the length of character variable can be ranged from 1 to 32,767 bytes. So here one character is equal to 1 byte. When you are creating a numeric variable, in numeric variable I can store only floating point numbers which has integer value or it can has a decimal value. It can be a positive value or it can be a negative value, and also it's going to store date and time value into its variable. So here you may have a question as date or time may have some special symbol, like if you see a date value, take any example of a date. For example, I have a date as 10/10/10, so October 10 2010. So in between these month date we can have some special symbol as a slash or a hyphen or 3-word month value, rest will be a numeric value. So how SAS is going to store a date value as a numeric variable or a time value as a numeric variable? So we'll see in upcoming slides. And second point tells you the length, the maximum length for a numeric variable is of only 8 bytes, but it can store up to 16 to 17 significant digits. So let us see one example how SAS is going to store a numeric value which has a range up to 16 to 17 significant digit, but the length is of only maximum of 8 bytes. But here one point we're going to see is that the length is not restricted to only 8 bytes. It can increase or decrease depending upon the requirement. So here one example is shown, like we have a data set called as an employees, where you have information of the employees like employee ID, first name, last name, title, letter of courtesy, birth date, hire date, city and address. So these are the type is nothing but your data type, number, text is nothing but your character, number is nothing but your numeric variable, and this is a length which has been assigned for these variables. Next, SAS date values. This is a very important thing what you have to remember in SAS, like how SAS is going to store its date value in the system, how it's going to represent the date values in its table when you assign a value to the SAS data sets, and also the time value and date and time. So we'll see one example. For example, when I'm trying to import a value as 1st Jan 1960 into the SAS system. So when I try to import, or when I try to assign 1st Jan 1960 value for an date variable, or value as 1st Jan 1961 or 1st Jan 1959. So in this case, how is SAS is going to store this value into the SAS table? When I assign this value to SAS compiler, SAS will store the value in the form of number. So number here indicates whenever SAS identify a date as 1st Jan 1960, internally these values are stored in the form of numbers. So here 0 indicate it's the first day of that date value. So when you go beyond a year, it is going to store again the value in the number of days, but in the negative prefix. Like when you start counting the days from 1st Jan 1960 to 1st Jan 1951, you'll find 365 days between 1 year. So when you go above that, you can find there are values as 366 because we have a leap year. So by considering a leap year as a value, it is going to store a value as 366, which means all the date values what are going to store in SAS are in the form of the number of days. But when you try to display the date values, you can display in any format. Like here I'm trying to display the date values in the form of year, day and month, or you can display in the form of month, day and year, month, day and year, month, day and year. It's up to you. Depending upon requirement, you can display in your own format. There is various formats, various in format are available in SAS. So a point has been highlighted here. SAS date values is stored as a number of days between 1st Jan 1960 and a specific date. So any date you specify. For example, if you assign a day as 1st Jan 2015, so it is around 20,000 days. When you start counting the number of days from 1st Jan 1960 to 1st Jan 2015, then the number of days can be up to 20,000. So same thing they're trying to explain in this slide. So any date value specified, always the date ranges in between the before or after the 1st Jan 1960. Any value which comes after 1st Jan 1960 will be in a positive integer. Any value which goes beyond in 1st Jan 1960, then it is in the form of negative number. Next, we have a quiz on this topic which we have studied on dates. So when you store or when you create a numeric variable, what's the default length? The default length of a numeric variable is of 8 bytes. So here you can decrease or increase the length of that variable, but the default length is of 8 bytes. Next, so this is also very interesting. Whenever you have a character variable or a numeric variable, so how SAS is going to treat the missing value for character variable and a numeric variable. So whenever you have a numeric variable, SAS will treat a missing value as a dot. Wherever in that column of a numeric variable you will find a value as a dot, which means it's a missing value. And for character variables, always the missing values are represented by a blank space. For example, in a fourth observation for a column job title, I don't have any value, so which means it's a missing. Whereas the second row of a salary variable, you can see there is a value as a dot, which indicates we have a missing for that particular employee. So this was about the fundamentals of SAS. Just you need to remember what are the different type of data types when trying to assign a variable length or a variable name or a dataset name. You need to follow the rules of the SAS. Otherwise, it will throw an error message. Like if you're trying to assign a dataset name or a variable name more than a 32 character long, then SAS will throw an error. Next is the very important. Again, here we're going to see what's the use of libraries in SAS. So what do you mean by SAS library? How to use SAS library? What exactly this SAS library are going to store? And what's the importance of SAS libraries? So here some of the importance of the SAS types are highlighted. So when we try to correlate libraries with the file system, so in the file system you can find there will be a folder. Within folder you can have subfolders, you can have various type of files can be stored within a single folder. You can store a document, you can store music, you can store video clip or any other files. In the same way, SAS library is a collection of SAS objects. SAS objects, it can be a dataset, it can be a format, it can be a macro. So here some of the important points has been highlighted about the SAS libraries. Like SAS library is capable of performing the following task. It can read, it can write a data. So when you want to create a new table or you want to access a table which is already present in your hard drive, then with the help of libraries you can access all the SAS dataset, or you can connect to other database or any other ERP system to access the table into the SAS system. So which is also used to list the files in the library. So what are the different kind of libraries contains? Like it can contains a data set, it can contains an object, it can contains a macro definition or a format. So all these files can be listed in the libraries. It can be used for renaming of a SAS dataset, or it can be used to delete permanently your SAS dataset. So which is also used to access the older versions of the SAS, and it can generate a new version of the SAS. It's also used to access our data from a database where SAS is having capability to connect to the database. It can store or access the files on the disk of the tape. So it's also determined to identify how many variables or how many observations are present in the table. Place data into memory from the physical location. So whatever the physical location, the dataset which are present in your hard drive, it can be loaded into the its RAM memory, which is also used to transfer files between one library to another library and files from one operating system to the another operating system. So before we move to the next slide, what we can see is that how this can be done in the SAS. So we'll see a demo of the SAS libraries in SAS, how these libraries are used in SAS to perform all the tasks, how exactly this library icon will look in SAS. So this is my home picture of the SAS environment. It's the home page of the SAS system. When you come to the Explorer window, which is at the left side, you can find we have a icon which represents the libraries. Double click on it, you can find few default libraries which are available in the system. So as soon as you restart or as soon as you start your SAS session, you can see some libraries which are always present in your system. So these libraries are predefined and created by SAS itself. So when you open this library, like for example, if I'm going to open maps, here you can find some of the tables which are already available, and also some of the objects. So this is my macro object where macro definition is defined. Similarly, when I open SAS help, you can see there are various macro definitions are already created by the SAS system. So here in my work I don't have any dataset or any kind of definitions created or any kind of SAS object is available in the work library. So we'll see in detail. So what are these libraries? What's the important of these libraries? You can see in my map I have a few information, I have few tables. In SAS help I have few tables and some objects. So similarly in SAS user I have, but whereas in my work this folder is completely, or this library is completely empty. So here you can see what are the SAS libraries and what are the different type of SAS libraries are available. So there are two kinds of SAS libraries. One is your temporary SAS library, and another one is your permanent SAS library. So here we're going to see how these two libraries are different and which library represent a temporary and what libraries are available for your permanent libraries. So as you have seen in the SAS environment, there was a library called as an work, there was a library called as an SAS help, SAS user. So this is one which is created by user called as an imart. So a name called as an work, so this is always a temporary library. So what exactly this temporary will refer? It refers to a storage space where whatever work you are doing is available for some instance in the sense, as soon as you restart your SAS session or you shut down your machine, so whatever the objects or what are the files data set present in the work library will be deleted permanently from the libraries, which means you don't have access to the files present in the work library when you restart your SAS system or when you restart your machine. Whereas the tables, objects which are present in library such as SAS help, SAS user or imart, so these are the permanent SAS libraries. Once you created the dataset in this library will be accessible until unless a user is going to delete them manually. So here SAS help, SAS users are system defined libraries. So what it means, these libraries are created by, so these libraries are created by system itself, whereas imart is my user defined libraries, whereas work is also my system defined library. Next, coming back to the SAS session, here I have four libraries. One is map, SAS help, SAS user and work. So here maps, SAS help, SAS user are permanent libraries which are created by system, so these are also a system defined library, whereas work is a temporary library which is created by system. So whenever you want to create your own library, so for that we have a statement. With the help of those statement and keywords I can create my own library, so that we call it as an assigning a library. So assigning a library is in the sense when user want to create his own library, at the time he can create his own library by using a statement or by using a keyword called as an libname followed by name of the library, and that should be assigned to some database or it should be assigned to some physical path. So before you create a library, let us see some of the rules for assigning a variable name. So what are the rules? So first rule tell you is that it should not exceed more than 8 characters, and second rules tells you it should always begin with an letter or it can begin with an underscore. Third rule, it must have letters, numbers or underscore. So here again no special symbols are accepted by the SAS compiler when you define a library. So let us try creating a library in our SAS. So first is that whenever you want to create A library in SAS, always you should start with a keyword called as an libname. So here libname can be in uppercase or it can be in lowercase or it can be both in mixed case. So SAS is not a case sensitive programming language. Libname followed by name of a library. So here my name of a library is imart. So here I'm not violating any of the rules. So here it's a less than 8 characters. It doesn't have any special symbol. Third parameter what you're going to pass is the path. What kind of path you're going to pass is that where exactly your tables are available. So in my case SAS dataset are available at this path. Just copy and paste that path within the single quotes or double quotes. Always path in SAS is referred within the single quotes or a double quotes. So when I'm going to submit this code to the SAS compiler by pressing F3, you can see a note is displayed in my log file which tells you library has been created or assigned successfully for the engine called as an V9 for the physical path, that is imart project. Again you can see in the Explorer window I have a new library called as an imart. So when I open this new library you can see there are few data sets. So these data sets were already present in my hard drive in this path. So here I have this data set which has been created earlier. Only what SAS is trying to do is that it's just trying to refer to this data set in my imart library, which means now what are the tables which are present in my physical drive in my hard disk, those tables can be accessed to the SAS system by using a libname statement. So for example here if I don't have any data sets, so here I will create a new folder here, like new assign here as a test. So in my test folder I don't have any SAS dataset, it's completely empty. And if I try to create a new library with any of the name called as an temp double quotes, assign the path, semicolon, run, shift home, press F3. Now let us see whether I have created a library called as temp or not. Yes, SAS has created a library called as temp, but in this temp library I will not have any SAS datasets because when I open that folder, in this folder the folder is empty. If there was already created SAS dataset were present in this folder, then you can view those dataset in my temp library. So same thing we're explaining in this slide. So here the important thing is that what you need to understand from this slide is that whenever you want to access SAS dataset which are already present in the hard drive, or you want to refer to any database, any RDBMS database, like it can be RDBMS or it can be a simple Excel spreadsheet. So those files can be accessed into SAS system by using a library name, by using a libname statement. Otherwise directly to access into the SAS it will be very difficult. Next, so here we have one more point, that is how to deassign a library. So what it means, so the above code which you have written in the SAS editor, what it does, it creates a library. Now whatever the library which I have created, I want to delete those library. Delete in the sense, just I want to deassign those library which I have created earlier. So those can be done by using same statement, that is libname followed by name of a library. So I'm assigning here as a temp and use a keyword called as an clear and with a semicolon. So once you submit this code to the SAS compiler, that library will be deleted from Explorer window. You can see that library has been deassigned. Similarly, if I try for IMART, so IMART, which is already present in my Explorer window, which is at the left side, when I submit this code to the SAS compiler, you can see that library has been deassigned. So deassigned in the sense, what are the reference which are made by using a lib name that has been just temporarily disconnected. But it doesn't mean that it has deleted all the tables from the physical path. No, it never does that. Simple, it just deassigns the reference, but the tables in my hard drive are still present. So if I want to delete those tables, again we have some other techniques. With the help of those techniques we can delete. Hope this is clear to you. What's the use of a library, what do you mean by a lib reference? Whenever you want to deassign the library, you can use the command as a clear, and you have seen some of their rules while creating the libraries. Next, so here they are explaining this is how you can browse your library. Just go to the Explorer window, double click on the libraries. Again, which library you want to explore, just double click on the library. You will find all the objects of that libraries which were earlier created. So next is browsing a SAS library. So whenever you want to browse a SAS library, just you can use a contents. So what it means, so already I think we have discussed about what is the use of a proc contains. So first I will assign the library, then I'm going to use procedure collision proc contains data equal to. So here I have to assign as imart dot followed by your table name. Just you can use any of the table name. For time being I'm using employees as my table name, and submit the code. So it will tell you all the general information of the table. So like it will tell you when it was created, when it was modified, how many observations were there, how many variables are there, what are the variables, what are the observations, what is the data type, what's the length, what's the format, what is the in format for that particular variable. So again we have an option called as an NODS. So NODS stands for no description. You can see in the output window it has thrown a lot of information for the table. Whenever you want to hide the information, you want to display only the basic information as only the name of a table, what's the member type, what's the file size, and when it was modified. Only a few information of the tables, and at the time you can use an option as NODS, and this can be used with only a keyword when you use a underscore all underscore. So underscore all underscore, what is going to do is that it will display the contents of all the available data sets in my IMART library with only the minimal general information of the table. Same thing we're going to explain in the slide, what is the use of NODS and when it can be used. Next, so on this whatever we have studied in library, we have a small quiz here. Consider we have a data set which has student ID, English, history, math, science as a variable, test score of 10 students. So just you need to find how many variables are there and how many observations are there. So total we have 5 variables and 10 observations. So every student will be one observation. So that's it about the introduction to the SAS. So here whatever we have seen is just a very basic introduction to the SAS, how exactly SAS environment will look like, what are the features of the SAS when you want to execute any code in SAS, how it can be executed. We have seen how SAS is going to compile and execute its program. So what happens during the compilation phase and execution phase. So what do you mean by SAS program? So SAS program has two parts. One is a data step and a proc step. So when you are going to use a data step, when you're going to use a proc step, and also we have seen the fundamentals of the SAS. So in fundamental of SAS we have seen what's the data type. So when you want to create uh, a table or a variable, so what are the rules you need to follow while creating a tables and variables. So also we have seen very important, that is what are SAS libraries, how to use SAS library, what are different type of SAS library, like we have temporary and permanent. Again, in temporary we have work, only one library is available. In permanent there are many libraries, so few are created by the system itself and few are created by the SAS. Also we have seen how to create a permanent library by using a libname statement, and whenever you have created a library you want to deassign that library, so how that can be done with the help of a libname.